Hello guys, welcome to my YouTube channel or David Structure Hub. So this is a place where you learn, build and innovate. Today I want to talk about understanding properties of materials, and before I can highlight or give you the subtopic I will be discussing under this topic, let me first define what a material properties is. So a material property is a characteristic of a material that defines how it behaves under various physical conditions such as force, temperature, pressure, or environmental exposure. So as an engineer, it's very important to understand some of these properties of a material. And what do you think is the importance of understanding this topic? So I'm going to highlight some of the importance of understanding of a material property. Number one, we have structural safety. Number two, we have accurate design. Number three, material selection. Number four is durability. Number five, sustainability. Number six, cost efficiency. Number seven, compliance with standard. Eight, performance in environment, innovation and failure prevention. So those are the importance of studying properties of a material. As an engineer, you should be known. And then, uh, number one, I will be talking about properties of steel as a construction material. Number two, I will be discussing about stress. And then number three, I will be discussing also about strain. Number four, I will be talking about stress strain curve. And then number five, that is Hooke's law and elastic module. Under that, I will be talking about Young's modulus of elasticity and then modulus of rigidity. And then the last one, I will be discussing about relationship between stress and strain. Under that, we have longitudinal strain, we have lateral strain, we have volumetric strain, we have Poisson's ratio, and the last one, bulk modulus. So guys, stay tuned for more about properties of materials. Let's talk about steel. Steel is a strong alloy primarily made of iron and carbon. Steel is widely used in construction due to its exceptional properties which make it reliable and versatile. And then some of the properties of steel, they include the following. Number one, ductility and malleability. What is ductility and malleability? It means steel can be rolled, bent, or welded into different shapes without failure. And then number two, durability and longevity. I will explain. So this is the resistance to wear and tear. And then elastic and toughness. I will also explain. Steel can return to its original shape after deformation. And what is toughness? Toughness, it is the ability to absorb impact energy without fracturing. Then we have the versatility. Steel can be adapted to various functions. Example, it can be used in reinforced concrete, steel frames. It can also be used in trusses for roofing. It can also be used in bridges, a railway track, and a pipeline. Another one is fire resistance and heat resistance. So, steel can withstand high temperature, especially when coated with fireproof materials. And then we have recyclability and sustainability. 100% recycled without losing strength, making it an eco-friendly construction material. And then the last one, we have high strength to weight ratio. High strength to weight ratio. High strength and compressive strength allowing the structure to withstand heavy loads without failure. So that is about steel. Stress is a force of resistance per unit area. So stress mathematically, this is the symbol for stress is equal to P over A, whereby P is equal to external force or load, and then A is the cross-sectional area. We have different types of stresses. Number one, tensile stress. I will explain. So the tensile stress is the stress that is induced in a body when subjected to two equal and opposite pulls, as a result of which there is an increase in length. And we have number two, compressive strength. I will explain. Compressive strength is a stress induced in a body where, when subjected to two pulls and the opposite force, as a result of which there is a decrease in length of the body. So something to note between these two types of stresses, tensile and compressive stress. So in tensile, it results into an increase in length of a body, and this one, it results into a decrease uh, in length of a body. And then we have the final one, the shear stress. What is shear stress? The shear stress is the stress induced in a body when subjected to two equal and opposite force, which are acting tangentially across the resisting section. So that is all about stresses. And let's talk about strain. What is strain? Strain is the ratio of change of dimension of the body to the original dimension. Uh, we have different types of strain. You have the tensile strain, volumetric strain, compressive strain, and the shear strain. So if you are following me, I want you to do more research about the strain. Uh, you know, you should know the difference between tensile strain, volumetric strain, compressive strain, and the shear strain. So I'm giving you something like an assignment. So do your own research and come up with your answers. Stress strain curve. So this is a curve produced uh, as a result of stress and strain. So the curve, it explains the mechanical behavior of a material, and the material I'm talking about is steel. So I want to explain what it means by elastic zone, plastic zone, straining hardening zone, failure zone, yield point, ultimate tensile strength, and fracture point. So I will explain this curve using the concept of scrap materials. I know here in Kenya, we do a lot of business from collecting scraps uh, to selling them to the people who buy it and take them to the factory for recycling. So at times, you have seen people collecting these scrap metals on the road, or even where the building or a building or a structure have been demolished. So the person who buy the scrap metal has a spring balance, like the one I'm drawing on the board. So this is the spring balance. So when you take those scrap metals to this person, he will take the scrap metals and put it here. scrap metals and the spring balance. So the scrap metals on this spring balance will pull the spring downwards, and then you will be able to read and give you the quantity of these scrap metals. Let's say 1 kg. So after doing so, he will remove these scrap metals from the spring. And if you observe, or if you have been observing keenly, if you are doing this business, you realize that after removing these scrap metals, the spring goes back to its original form or shape. So we say that this spring is in elastic limit. So the spring is also an elastic material. Why? Because it can be stretched under loading, and then after removing the loading, it goes back to its original form. So on the curve, we have an elastic zone. So this elastic zone is when a material is loaded with when a material is loaded, and after removing the loading, the material goes back to its original form. So we have at this point, it's called proportional limit. So it means at this point, if you continue loading this spring, it will start deforming, because the loading is now exceeding what the spring can carry. Again, if this person uh, selling or buying these scrap metals, he or she continue loading this spring, you will realize that it will reach a time when the spring will no longer sustain the loading. So if he loads something that is heavier than the spring can carry, yes, the spring will stretch. And then after he or she removes the spring can no longer go back to its original shape or form. It means the spring will have stretched a little bit longer than the original length. So now this zone is what we call plastic zone. Now the spring is now deforming, has now started deforming, because the person selling the scraps is now exceeding the loading the spring can carry. So the loading at this point is what we call yield point, in bracket Fy. Again, if the person buying the scrap continue loading this spring, continue loading and loading and loading, and after loading several times, or with a heavier loading, when he removes the loading, when you observe the spring will again increase the stretching. It means it can no longer go back to its original form and shape. So this is what we call strain hardening zone. Now the spring continues stretching and stretching and stretching. So at this point, this is what we call ultimate tensile strength. It means at this point, this is the point where you can load the spring with the maximum loading. The maximum loading. This maximum loading will result into an increase in the spring length. And then if you load beyond this ultimate tensile strength, it means that now the spring will fracture or it will break. The spring can no longer hold or can no longer hold the loading beyond this point. So that's why the curve is now going downward. So this point or this zone, we call it failure zone. And at this point, now the spring will fracture or it will break. So this concept is used to test the strength of the reinforcement bar in laboratory. So it is very important to understand this stress strain curve for the analysis of structural element. Hooke's law and elastic module. Hooke's law states that when a material is loaded within an elastic limit, the stress is proportional to the strain produced by the stress. So if I can again draw the curve, so this is the proportional limit. At this point, this is the proportional limit. So it means if a material is loaded within an elastic limit, the stress is produced, the stress is proportional to the strain produced. So this is the stress and this is the strain. And this is elastic zone. So if a material is loaded within this zone, then it means the stress is proportional to the strain produced. So we can express this mathematically by saying that if a material is loaded within an elastic limit, the stress is proportional to the strain produced by the stress. So stress is directly proportional to strain within an elastic limit. So this is an elastic zone. So if a material is loaded within this zone, then it means the stress is directly or is proportional to the strain. So if we say stress is equal to E, E times strain. So I have just introduced a constant and give it E. So if stress is equal to E times strain, it means this is a symbol for stress. E times strain. This one is for strain. It means if I divide both sides by strain, I will have E equals to so E will be equal to stress over strain. So in properties of a material, E is what we call E is equal to Young's modulus, or a modulus of elasticity. So modulus of elasticity uh, is defined as a measure of stiffness of a material, uh, and is the ratio of stress to strain in a material within an elastic limit. So what is Young's modulus? So Young's is the measure of stiffness of a material, and is defined as the ratio of stress to strain in a material within an elastic limit. So uh, Young's modular is a very important not parameters in structural analysis, because this is a parameter that measures the stiffness of a material, how a material. The last section, under understanding properties of a material, I'm going to talk about the relationship between stress and strain. This one is given by Hooke's law, whereby the normal stress over corresponding strain is equal to constant. You have seen that. Or stress over strain is equal to E, where sigma is equal to normal stress and E is equal to strain, and E is equal to Young's modulus of elasticity. So under this relationship between strain and relationship between stress and the strain, I'm going to define the following terms. Number one, we have the longitudinal strain or linear strain. So this is the ratio of axial deformation to the original length. So the longitudinal strain is equal to change in length over L, where change in length is the increase in length of the body and L is the length of the body. And then we have the lateral strain. So the lateral strain is the strain at right angle to the direction of the applied force. And then we have Roman 3 volumetric strain. Volumetric strain is the ratio of change in volume to the original volume when a material is subjected to a uniform pressure. And then we have the Poisson ratio, symbolized by V. This is the ratio of lateral strain to the longitudinal strain. And then we have bulk modulus, symbolized by K. So this is the ratio of the volumetric strain to volumetric, no, this is the ratio of volumetric stress to volumetric strain. So that marked the end of understanding properties of a material. If you have any question, you can ask through a comment section. So you can also like, you can also share this content to your fellow colleagues, and let's all learn structure.